All right, so this is a little bonus content, if you will. I just got done filming my part A and B for exponents. And I was thinking, sometimes when I teach this in class, I give a little bit of extra explanation if people are interested on why the exponent rules work. Okay, so referring to these exponent rules here from the notes from 13.2/13.5. So let's start with number 1. So you're multiplying two things that have the same base. All right, so let's say you want to multiply x squared times x to the third. Okay, well, x squared could be written as x times x, and then x to the third power could be written as x times x times x. All right, so you've got x times x times x times x times x, right? So there's 1, 2, 3, 4, 5 of those. So that's the same thing as saying x to the 5th power. All right, so what the rule is telling us is that we can basically just shortcut that and add 2 plus 3 to get 5. All right, so then rule number 2, which is the fraction, turns into a subtraction. Okay, so let's say in that case, so this was referring to rule number 1. So rule number 2, let's say that we were doing x to the 6th power over x to the 4th power. Okay, well, x to the 6th power, 1, 2, 3, 4, 5, 6, right? And then over x to the 4th, so 1, 2, 3, 4. Okay, well, we would just cancel like so, and we would have, what we have left would be x squared. So the rule is just basically a shortcut telling us that we can subtract 6 minus 4 to get 2. Okay. Okay. And then let's see. Rule number 3 is telling us that we can, if we have an exponent and we raise it to another exponent, we multiply the exponents. All right. So, for example, let's say we have x to the 3rd power squared. Okay, well, when you square something, you multiply it times itself. So that would be the same as saying x to the 3rd power times x to the 3rd power. Okay, and then we could use rule number 1, which we've already covered, to know that we would just add those together. 3 plus 3 is 6, so it would be x to the 6th power. And then the rule is basically telling us a shortcut. We could have just multiplied 3 times 2 to get the 6. So the rules are really shortcuts. Maybe we should call them exponent shortcuts. It makes them sound a lot more friendlier than rules. Okay. So then let's see. I guess we could go ahead. Let's see. Let me go to number 5 and 7, because 4 and 6 kind of go together. 5 and 7, actually, it's kind of interesting the way these are laid out, because I don't know, I think these kind of go together. And these kind of go together. Let's see. Let's say, what if we have x to, let's say x squared over x to the 5th. Okay. All right, so x squared is x times x. And then x to the 5th, we've got 1, 2, 3, 4, 5. And then we go cancel, cancel. So when we cancel those, you know, what we're really saying is it's like x goes into x one time. X goes into x one time. So we're left with a 1 in the numerator. And then in the denominator, we've got 3 of those, so that's going to be x to the 3rd power. See, when something is in the denominator, it has to still be in the denominator. So basically, if you don't have anything left on top, you just have a 1 there. Okay, so that's one way to look at that problem. So, however, if we use rule number 2, and we subtract 2 minus 5, we get -3. Okay, so this explains rule number 7, I would say. This is showing how that x to the power of -3 is equal to, is equal to 1 over x to the 3rd power. Okay, let's see. Okay, so let's see about what if we had, let's say we had x to the 3rd power over x to the 3rd power. Okay, well, if we use, again, rule number 2, subtract the exponents, 3 minus 3 is 0, so that would be x to the 0. However, we also know that anything divided by itself is always equal to 1. So that explains rule number 5, why x to the power of 0 is always equal to 1. Okay. Let's see. And then I guess let's talk about rules number 4 and 6. Like I said, those kind of go together. So for that, let's say we have xy squared. Well, when you square something, you multiply it times itself. So that would be xy times xy. And then we know we could put our invisible ones here if you like, or we could just know that x times x is x squared and y times y is y squared. And then what that rule is telling us is that as a shortcut, we could just distribute that exponent and get the same answer. And then rule number 6 is basically the same thing. You know, if you had x over y squared, that you could call that x over y times x over y. And then we know x times x is x squared and y times y is y squared. Or you could just use the rule, aka the shortcut, that lets you distribute that. All right, so there's my explanation on why those quote-unquote rules are really just handy little shortcuts. Hope you find it helpful.